friends. Today in this video we are going to study about LZW compression algorithm. This is a technique which is used for lossless encoding. The data is encoded and then it is retrieved without any losses in the data. So just similar to LZ77 and LZ78 techniques in which we used to have triplet and doublet representations of the data, we are now going to study about LZW technique, in which you do not need any triplet or doublet representations. You simply need an index on the receiver side, and with the help of that index you can actually recover your data. Another very important point about this LZW compression algorithm is that the symbol on which you end your encoding, in the next iteration the encoding will start from that last symbol which you used in the previous encoding. For example, if this is your symbol that you were encoding in the first iteration and it ended here, maybe on A, B, C, whatever the character it is. So when you do the second iteration of encoding, you will start your encoding right from here. So this digit or this character will be your first character in your next iteration. So these are two very important points that you have to keep in mind. And now keeping these 2 points in mind, we will jump on to a very simple and very easy to understand example, with the help of which we are going to understand this compression technique. So I have taken a question in which I am given with a string, and this string needs to be encoded with the help of this LZW encoding. So first of all, you have to remember that this encoding technique always comes up with a dictionary. So your initial dictionary that is given to you with the question is that A is represented with index 1, B is represented with index 2, and C is represented with index 3. So basically these characters which are present in your string, they have been represented with some index values. As I just mentioned to you that this technique only depends on index values. So these index values have been given to you in the dictionary. Now with the help of these index value, you are supposed to transmit this string by encoding. Okay, so I am going to draw a table like this, in which there will be a column for encoded output, and there will be a column which you call dictionary. Within dictionary there will be 2 sub columns. One will be your index that is given to you, and one will be your entry. So one by one I am going to I'll do this on this paper as well for your ease of understanding, and I will show it to you to this solution as well. So for this given string, first character that is present in the string is A. So I am going to write down this data entry over here, A. So do you know what is the index given to you for this A? You will go and search from your dictionary, and yes, for A I am given index 1. So I will simply write 1 for this data entry. Okay, now come on to the next element from your string. The next element is B. So you will write down B in your next entry. And okay, what is the index given to you for B? So you will again go and consult your dictionary, and you can see that for B the index given to you is 2. So you will simply write down 2. By now you are not getting any sort of encoded outputs. All right. Okay, so now let's see that for C you have another entry in your dictionary which is C. So for C, what is your index value? The index value for C is 3. Again, this value has came to you from this dictionary. So all the values for which have came directly from the dictionary, you have not generated any encoded output. Now let's go on to the string. Previously we were not consulting the string, we were simply taking the entries from dictionary and writing down their indexes. Now friends, I'm going to go on to my string. So the first element in my string is not A, because A is already present in my entry book. So I will take AB. So for AB I will say that okay, for AB the index value will be incremented by 1. So by 3 I was already having index values, so next index value will of course be 4. So for this next index value, what will be the encoded output? So you can see that for this, the first element of this data entry, the first element of this data entry is A. You can see that A is the first element of this data entry, and the index of this first value A is 1. So I will write down that the encoded output for this smaller chunk of string is 1. Okay, now let's go on to the string once again, and I told you that in LZW we always consider the last element of the previous encoding as well into your next iteration. So I will not directly jump on to this A. I will start from this B again, although I considered this A and B in my previous iteration, but again my pointer will be pointing here on this B. Okay, so then I will consider B and A together, and I will write them down as my next data entry. So for this B and A, you can see I will give it the index location 5, just incrementing 1 each step, and the first and data point in this complete mini substring is B, and you know that the index value of B is 2, so that is why you will write down the encoded output as 2. Okay, all right. So next iteration will be from in the next iteration, although I have considered this complete value in my previous iteration, but I will not simply jump here. I will jump on to the previous last element of the previous iteration, and I will consider this A and B. But you can see that A and B have already been considered here, so I will not consider A and B again, otherwise it will be again the same output. So this time I will consider A, B and B. So I have written A, B and B. Okay, so index will be just incremented by 1, and you can see that the first element of this substring is this A and B together. So what is the value of A and B? You can see that the value of A and B, the index value of A and B is 4. So I will write down that the output for this complete substring is 4. It has came from here because you know the first elements are A and B. Okay, so now from this A and B, from this data point I have to jump over here. This is the last element of my previous iteration. Okay, I can take BA because BA is already considered on this step, so I will not take BA to again because it will generate same encoding output. So then I will take BA and B. Okay, so now for you can see that for B, A and B you will simply increment the index location by 1, and you can see that the first data in this B, A and B is this value BA, and for BA you can see that the index value is 5, so this 5 will come here for this complete string BAB, right? Okay, so now after this BAB I will again place my pointer here on this B, and you can see that BC is a new data entry which was not considered previously, so I will bring B and C here. So you can see that the first data entry of this string is B, and for B your index value was 2. So the encoding output or the encoded output for this data BC will come out as 2. Okay, so now I will again come on to bring my pointer here on C, and I can consider this CA together, and I will place them here because you know CA was not in the table previously. Okay, for CA you can see that the first data entry is C, and for C we were having the index equal to 3, so this 3 will come down here for this data as the encoded output. Alright, so after CA the pointer will come over here, and if I consider AB, you know that the AB was already there in the data entries, and if I consider ABA, so I can check it from the table. A B B A B B B A B is there. Okay, A B A is there. Oh yes, so basically I will for the next point you can see that you are standing on this A, and A is your next value because it was not there, so I considered ABA, and the first data entry of this substring is AB, and you can see that the value of AB is 4, so I have placed 4 here as the encoded output. Okay, so now from ABA move your pointer here on this A, because this is the last element of your previous iteration. So now you will can consider AB, it was already there. ABB, it was also already there in your data entries. So ABA, you will consider this complete mini string ABBA, and the first element of the string is ABB, and the code the index of ABB is 6, so 6 will come here. So now this is your basically encoded output, so you will write it down here: 1 2 4 5 2 3 4 6, 1 2 4 5 2 3 4 6. Okay, so in this way you can see that for this complete string you have got this encoded output. So actually you can see that 1 2 3 4 5 6 7 8 9 10 11 12 13 14, basically 14 characters have been represented by 1 2 3 4 5 6 7 8 8 integers. So it is the best dictionary based technique which is used for encoding, and it is basically lossless encoding. You do not get any sort of losses when you uncompress this data. So this is how you do LZW in compression algorithm. I hope you understand it, and if you have any questions about it, you can write them down and you can post them in the comments section. Thank you very much. Allah Hafiz.